Good morning all. So in today's class we will look at how to solve for a second order differential equation about a regular singular point. So you have an equation of the form y double dash plus p of x y dash plus q of x y equal to 0, where your functions p and q have singular points and those singular points are regular singular points. So we will look at how to find out the solution in this case. Now for finding the solution, we use a method called the method of Frobenius. So in today's session, we'll see how to solve for an equation using the Frobenius method. Now for solving a differential equation at a regular singular point, so usually when you have an ordinary point, we assume that solution is of the form y equal to summation a naught x raised to n, a n x power n. So when you have a regular singular point, we guess that the solution is of the form x raised to m into a naught plus a1x plus a2x square plus a3x cube plus etc. So here m may or may not be an integer. So this series of this form is called the Frobenius series. So we assume that our solution is of this form, and let us look at how to solve for an equation with regular singular points. So we'll start with an example, and later on we'll go on to the theory. Okay. So the first question is, use the method of Frobenius series to solve the differential equation 2x square y double dash plus x into 2x plus 1 y dash minus y equal to 0 about the regular singular point 0. Now let us write this equation in the standard form. That is y double dash plus p of x y dash minus plus q of x y equal to 0. Okay. Let us check whether, so the only singularity is x equal to 0. So let us check first of all whether it's a regular singular point or not. If x into p of x എടുക്കുമ്പോൾ you will get 2x plus 1 by 2. This is an analytic function. And അതുപോലെ x square q of x എടുക്കുമ്പോൾ you will get minus 1 by 2. So that's a constant which is again analytic. So therefore x into p of x and x square into q of x are analytic. അതുകൊണ്ട് നമ്മുടെ x equal to 0 എന്ന് പറയുന്ന singularity, that will be a regular singular point. Now we are going to assume that the solution is of the form x raised to m into summation n equal to 0 to infinity a n x raised to n. So you can write y in the form. So y is going to be a naught into x raised to m plus a1 into x raised to m plus 1 varum a2 x raised to m plus 2 plus etc. ഇനി അതുപോലെ നമുക്ക് y dash വേണം, y double dash ന്റെ value വേണം. So the you have y, when you take the derivative you will get y dash will be a naught m x raised to m minus 1. അതുപോലെ second derivative, second term you will get a1 into m plus 1 x raised to m varum, then a2 into m plus 2 x raised to m plus 1 plus etc. അതുപോലെ second derivative എടുക്കുമ്പോൾ you will get a naught m into m minus 1 x raised to m minus 2 varum, then a1 into m plus 1 into m x raised to m minus 1, then a2 into m plus 2 into m plus 1 x raised to m plus etc. Now when you simplify the equation you will get y double dash plus 2x by 2x square by 2x square 1 varum, then here 1 by 2x varum, y dash minus 1 by 2x square y equal to 0. Now let us substitute the values of y dash and y double dash. So upon substituting, so this will be the term for y double dash is series varum. Then you have y dash substitute here, then 1 by 2 x y dash. So I have divided here by x from a naught m x raised to m minus 2 varum, then a1 into m plus 1 x raised to m minus 1 varum. Then a2 m plus 2 into x raised to m etc. Okay. So that will be the value. Then the next term minus 1 by 2 x square y. So minus 1 by 2 into y in x square which divide a0 x raised to m minus 2 varum. A1 x raised to m minus 1. Then a2 x raised to m. So now this is our equation. Now let us equate the coefficients to 0. So when you equate the coefficients to 0, so we will get the value for m, a0, a1, a2, so on. ഇനി നമ്മൾ ഈ സീരീസ് നമ്മൾ assume ചെയ്യുമ്പോൾ here you assume that y is of the form x raised to m into a0 plus a1x plus a2x square plus etc. So here a0 is always non-zero. a0 non-zero ആയിരിക്കും നമ്മൾ ഈ Frobenius series എടുക്കുമ്പോൾ. അപ്പം now let us equate the coefficients on both sides. അപ്പോൾ ആദ്യം ഞാൻ x raised to m minus 2 ന്റെ coefficient എടുക്കുമ്പോൾ I'll get a0 m minus 1. Then here you have a0 m by 2, then minus a0 by 2 equal to 0. Now by our assumption a0 is not equal to 0, the product is 0 ആണെങ്കിൽ this must be equal to 0. So, this first equation will give you the value of m. Now e equation ആണ്. So this is actually called the initial equation of the differential equation. So here a0 is not equal to 0. So you will get an equation which is in the form m into m minus 1 plus p0 into m plus q0. So ഈ ഫങ്ഷൻസ് നമ്മൾ എക്സ്പാൻഡ് ചെയ്യുമ്പോൾ നമുക്ക് കിട്ടുന്ന വാല്യൂസ് ആയിരിക്കും. ഓക്കെ, സോ come to that. So this equation is called as the initial equation. So from the first equation, since a0 is not equal to 0, this will be equal to 0. So from here you can solve for the value of m. Okay. Similarly, x raised to m minus 1 in the coefficient എടുക്കുമ്പോൾ ഇതായിരിക്കും equation വരിക. x raised to m in the coefficient എടുക്കുമ്പോൾ നമുക്ക് കിട്ടുന്ന equation ഇതായിരിക്കും. Okay. So let us solve for the initial equation first. So initial equation എന്ന് പറയുന്ന m square minus m by 2 വരും, minus 1 by 2 equal to 0. So upon solving you will get m1 equal to 1 and m2 equal to minus 1 by 2. So these are the values that m can take. So m will be either 1 or minus 1 by 2. ഇനി നമുക്ക് ഈ രണ്ട് m valuesഉം substitute ചെയ്തിട്ട് നമുക്ക് a1 a2 ന്റെ value കണ്ടുപിടിക്കാം. So let us first find the value when m1 is equal to 1. Okay. So m1 equal to 1 ആണ്, and let us substitute in the second equation. So we can obtain a1, a2, a3 etc. in terms of a0 once you get the value of m. For m in the value 1 substitute here, so you will get 2a1 plus a0 plus a1 varum minus a1 by 2. So this will be the first equation. So you will get 5 by 2 a1 plus a0 equal to 0. So that will give a1 equal to minus minus a0 into 2 by 5 varum. So that is minus 2 by 5 a0. അതുപോലെ substituting m and a1 in the second equation. So we can obtain the value for a2 for രണ്ടാമത്തെ equation substitute ചെയ്യുമ്പോൾ you will get a2 into 6 minus 4 by 5 a0 plus 3 by 2 a2 minus a2 by 2 equal to 0. So 3 by 2 minus 1 by 2, that will be equal to 1. You will get 7 a2 equal to 4 by 5 a0. So a2 will be 4 a0 by 35 varum. So we have got the value of a2. Now let us substitute the value of m2. So 1 by minus 1 by 2 substituting. Substituting minus 1 by 2 in the second equation, you will get so you will get minus 1 by 4 a1 minus 1 by 2 a0 plus a1 by 4 varum minus a1 by 2 equal to 0. So that will be a1 into minus 1 by 2 equal to a0 by 2. So that will give a1 equal to minus a0. So a1 you have obtained in terms of a0. In the മൂന്നാമത്തെ equationൽ m ന്റെയും a0 ന്റെയും a1 ന്റെയും value substitute ചെയ്യുക. So that will give the value for a2. So a2 into 3 by 4 varum plus a1 into 1 by 2 plus a2 into 3 by 4 minus a2 by 2 equal to 0. So when you simplify, you will get so here you will get 3 by 2 minus 1 by 2, again 1 varum. So a2 will be equal to minus a1 by 2. So replacing a1 in terms of a0, you will get a2 equal to a0 by 2. So that's the value for a2. Now we can find out the corresponding Frobenius series when you have m equal to 1 and m equal to minus 1 by 2. Now m equal to 1 in the value you will get a0. a0 is common in every term. So x power m into the remaining series. So you will get x power 1 into first term a0, then a1x plus a2x square plus x. So a0 common ആണ്. a0x into 1 minus 2 by 5x plus 4 by 35x square plus etc. വരും. ഇനി അതുപോലെ second value of m is minus 1 by 2. Again a0 is common. X raised to m2 into a0 plus a1x plus a2x square. That will be the Frobenius series. So you will get a0 into x raised to minus 1 by 2 into 1 minus x plus x square by 2 plus etc. So now you have got the independent solutions y1 and y2. Now if you want, we can ignore a0. a0 no 1 ennu kodukka. So when you write the general solution, that will be c1 y1 plus c2 y2. So you need not put the value of a0 there. So that is c1 into x into 1 minus 2 by 5x plus 4 by 35x square plus etc. And c2 x raised to minus 1 by 2 into 1 minus x square plus x square by 2 plus etc. So this is the required Frobenius series solution. Now when you have a general equation of the form y double dash plus p of x y dash plus q of x y equal to 0. So if x equal to 0 is a regular singular point, so your equation can be put in this form. Okay. So here നമ്മൾ ഇങ്ങനെയാണ് നമ്മുടെ ടേംസ് എങ്കിൽ ഞാൻ x equal to x into p of x ചെയ്യുമ്പോൾ എനിക്ക് വരുന്ന ഈ സീരീസ് ആയിരിക്കും. ദാറ്റ്സ് ആൻ അനലിറ്റിക് ഫംഗ്ഷൻ. അതുപോലെ x square into q of x വരുമ്പോൾ ഈ സീരീസ് ആയിരിക്കും വരിക, which is again analytic. So if you equate the coefficient, നമ്മൾ ഇവിടെ ചെയ്ത പോലെ തന്നെ x raised to m minus 2 ന്റെ coefficients നമ്മൾ equate ചെയ്യുമ്പോൾ, so here we are going to get equation in the form m into m minus 1 plus mp naught plus q naught equal to 0. So this is the initial equation of the general differential equation. When you have equation in this form, so this is going to be the initial equation. So that is m into m minus 1 plus mp naught plus q naught equal to 0.